In the present lecture, we will discuss the how to solve the linear programming problem by simplex method. Let's see the problem. Solve the following LP problem. Maximize z equal to 3x1 plus 5x2 plus 4x3 subject to 2x1 plus 3x2 plus x3 less than or equal to 30, x1 plus x2 plus 3x3 less than or equal to 30, x1 plus 3x2 plus x3 less than or equal to 24, and x1, x2, x3 greater than or equal to the 0. Before starting the solution, first you have to observe the objective function and observe it is the maximization model or minimization model. If the objective function is minimization model, then convert into maximization by multiplying with the -1. But here given objective function is maximization model, so no need to multiply with -1. Okay, let's see the solution. First step is convert the inequality of the constraint into an equation by introducing the slack variables s1, s2 and s3. Here three constraints are given and all these three constraints are having the less than or equal to inequality symbol. So we have to introduce the slack variable s1 in the first constraint and introduce the slack variable s2 in the second constraint. Similarly, we have to introduce the slack variable s3 in the third constraint. Then the constraints will become the 2x1 plus 3x2 plus x3 plus s1 equal to 30, x1 plus x2 plus 3x3 plus s2 equal to 30, x1 plus 3x2 plus x3 plus s3 equal to 24, and x1, x2, x3, s1, s2, s3 all are greater than or equal to the 0. Then express the objective function with basic variables as well as with the slack variables. Then objective function will become the maximize z equal to 3x1 plus 5x2 plus 4x3 plus 0s1 plus 0s2 plus 0s3. Second step is find the initial basic feasible solution. Here number of equations are the 3 and number of variables are the 6. Then to solve the equations, initially we are considering the basic variables, that is x1, x2, x3 are the 0. So we have to considering the basic variables x1 equal to 0, x2 equal to 0 and x3 equal to the 0. Then substitute these basic variables in the constraint equation. Then we will be get the slack variables values. Then s1 value is the 30, s2 value is the 30, s3 value is the 24. Third step is construct the initial simplex table. This is the initial simplex table and here b is the basic variable. Initially we are considering the slack variables are the basic variables. So substitute the s1, s2, s3 in the b column. So I have to substitute in the b column s1, s2, s3 because these are the basic variables. CB is the cost coefficients of the basic variables. For this we have to observe the objective function and cost coefficients for the s1, s2 and s3 are the 0. So we have to substitute the s1 value is the 0, S2 value is the 0 and S3 value is the 0 in the CB column. Next, XB is the basic feasible solution for the respected variables. So substitute the S1 equal to 30, S2 equal to 30 and S3 equal to the 24 in the XB column. So next to Cj is the cost coefficients for the variables. For this we have to observe the objective function. And here x1 coefficient is the 3 and x2 coefficient is the 5 and x3 coefficient is the 3, s1 coefficient is the 0, s2 coefficient is the 0 and s3 coefficient also 0. Next observe the first constraint equation, that is the 2x1 plus 3x2 plus x3 plus s1 equal to 30, and observe the coefficients of the all the variables. Here x1 coefficient is the 2 and x2 coefficient is the 3, x3 coefficient is the 1, s1 coefficient is the 1 and for the s2 coefficient is the 0 and x3 coefficient also 0. Then I have to substitute these coefficient values in the s1 row, that is x1 coefficient is the 2, x2 coefficient is the 3, x3 coefficient is the 1, x1 coefficient is the 1, s2 and s3 coefficients are the 0. Next observe the second constraint equation. Here x1 coefficient is the 1, x2 coefficient is the 1, x3 coefficient is the 3, s1 coefficient is the 0, s2 coefficient is the 1, s3 coefficient is the 0. Next observe the third constraint equation, that is x1 plus 3x2 plus x3 plus s3 equal to 24. And here x1 coefficient is the 1, x2 coefficient is the 3 and x3 coefficient is the 1 and s1 and s2 coefficients are the 0 and s3 coefficient is the 1. This is the initial simplex table. Next step is calculate the values of Z4 minus C4 and check the basic feasible solution for optimality. And conditions are for the Zj minus Cj. If all the Zj minus Cj is greater than or equal to the 0, then optimal solution is obtained. And second condition is if at least one Zj minus Cj is the negative, then indicated by the arrow, and this column is called as the key column. And third condition is if more than one Zj minus Cj is the negative, then choose the most negative of them and this column is called as the key column. So first I have to calculate the Zj minus Cj for the first column. Here Zj minus Cj equal to summation of Cbj into Xj minus Cj. So first I have to calculate the Zj minus Cj for the first variable, that is x1. Then Z1 minus C1 equal to Cb x1 minus C1, and Cb into x1 will become the 0 into 2 plus 0 into 1 plus 0 into 1 minus C1, which is the minus 3, and this will become the minus 3. So Z1 minus C1 for the x1 variable is the minus 3. So next we have to calculate the Z2 minus C2 for the second variable, that is for the x2, and this will become the 0 into 3 plus 0 into 1 plus 0 into 3 minus 5, which is equal to the minus 5. Next we have to calculate the Z3 minus C3 for the third variable, that is for the X3, and this will become the 0 into 1 plus 0 into 3 plus 0 into 1 minus 4, which is equal to the minus 4. Next to calculate the Z4 minus C4 for the fourth variable, that is S1 variable, and this will become the 0 into 1 plus 0 into 0 plus 0 into 0 minus 0, which will become the 0. Next we have to calculate the Z5 minus C5 for the S2 variable, which is equal to the 0 into 0 plus 0 into 1 plus 0 into 0 minus 0, which is equal to the 0. And next one is the Z6 minus C6 for the sixth variable, that is for the S3, which is equal to the 0 into 0 plus 0 into 0 plus 0 into 1 minus 0, which is equal to the 0. So here observe the Zj minus Cj values are the minus 3, minus 5, minus 4, 0, 0 and the 0. So here all Zj minus Cj values are not greater than or equal to the 0. So there is no optimal solution is with these variables. And one more thing, here Zj minus Cj values are the more than the one value. So here minus 3, minus 5 and minus 4 are the negative values. So in this condition I have to choose the most negative Zj minus Cj values. Here most negative Zj minus Cj value is the minus 5. And for the x2 column, so for x2 column we are calling as the incoming vector, and also we are calling as this is the key column. So here most negative value is the for the x2 column. So x2 column we are calling as the key column, and this x2 vector we are calling as the incoming vector. So x2 variable will enters into the basis. Next step is calculate the minimum ratio of xb divided by ck. Here ck is the key elements for the respected values of xb, and ck value should be greater than the 0 only. And here key column is the x2 column. So ck values are 3, 1, 3 for the xb values of 30, 30 and the 24. So next we have to calculate the ratio of xb divided by ck for the S1 row. So for the S1 row xb value is the 30 and ck value is the 3. So xb divided by ck will become the 30 divided by 3, which is equal to the 10. Next we have to calculate the xb divided by ck for the S2 row. For the S2 row xb value is the 30 and ck value is the 10. Then xb divided by ck equal to the 30 divided by 1, which is equal to the 30. Similarly, we have to calculate the xb divided by ck value for the S3 row. For the S3 row xb value is the 24 and ck value is the 3. Then xb divided by ck equal to the 24 by 3, which is equal to the 8. So xb divided by ck values are the 10, 30 and 8. Among these values we have to identify the minimum value. So here minimum value is the 8 for the S3 row. So S3 row we are calling as the key row, and this is also we are calling as the outgoing vector, So basic variable S3 is leaves from the basis. So next we have to identify the common element in the key row as well as in the key column. So here key column is the x2 column and the key row is the S2 row. Then common element in the key row as well as the key column is the 3, and this 3 we are calling as the common element. So that is the key element we are calling as key element. Next step is construct the new simplex table by entering the incoming vector to improve the basic feasible solution. This is the new simplex table. Here we have to replace the outgoing variable S3 with incoming variable x2. So we have to write down the x2 in the basis of the new simplex table. Similarly, write down the its coefficient value is the 5 in the CB column. So then we have to modifying the old simplex table to improve the basic feasible solution with the following row operations. Here R1 volt, R2 volt and R3 volt are the row 1, row 2 and row 3 for old simplex table, and R1 new, R2 new, R3 new are the row 1, row 2, row 3 for the new simplex table. And always remember before applying the row operations, that is in the incoming variable column values of the new simplex table should be 1 at the key element and remaining value should be the 0. So key element is in the third row and x2 column. So in this position, so x2 column and third row. So in this position we have to get the value 1, and remaining positions the value should be the 0. So for this we have to do the following row operations. That is, first row operation is the R1 R3 new equal to R3 volt divided by key element. Here key element is the 3, so it become the 1. So when multiplying with the 3, and that is 3 by 3. So which means 3 by 3 is the, we can be say that one the row 3 volt divided by the 3. So that is the first row operation is the R3 new will become the R3 volt divided by 3, because 3 is the key element. So first I have to do the first row operation, R3 new equal to R3 volt divided by 3. So first I have to write down the R3 volt elements, that is 24 and 1, 3, 1, 0, 0 and 1. Then R3 volt divided by 3 will becomes the 24 by 3, which is equal to 8, and 1 divided by 3 1 by 3, 3 divided by 3 1, and 1 divided by 3 1 by 3, 0 by 3 0, 0 by 3 0, 1 divided by 3 which is equal to 1 by 3. So then you have to enter these values in the R3 new simplex table. So row 3 values will become the 8, 1 by 3, 1, 1 by 3, 0, 0 and 1 by 3. Next we have to get the 0 and 0 in the x2 column of the new simplex table. For this we have to do the following row operations. So first we have to do the row operations for the row 1. So for this I have to observe the in the old simplex table at the row 1 position and the x2 column position. and here its value is the 3. So here I have to get the 0. How we will get the 0 here mean? So 3 minus 3. So which means we can be say that one 3 minus 3 into 1 we will get the 0. So 3 is the which is mean R1 volt minus 3 into 1 mean R3 new. So next row operation is the R1 new equal to R1 volt minus 3 into R3 new. So first I have to write down the R1 volt elements, that is 30, 2, 3, 1, 1, 0, 0. So next to write down the R3 new elements, that is 8, 1 by 3, 1, 1 by 3, 0, 0, 1 by 3. But our row operation is R1 volt minus 3 R3 new. Then I have to multiply with the 3 for the R3 new. Then 3 R3 new will become the, so 8 into 3, 24, 1 by 3 into 3, 1, 1 into 3, 3, 1 by 3 into 3, 1, 0 into 3, 0, 0 into 3, 0, 1 by 3 into 3, which is equal to the 1. Then I have to do the row operation is R1 volt minus 3 R3 new, that is 30 minus 24, which is become the 6, 2 minus 1, which is become the 1, 3 minus 3, which is the 0, 1 minus 0, 1, sorry 1 minus 1, which is the 0, 1 minus 0, 1, 0 minus 0, 0, 0 minus 1, which is the minus 1. So enter these values in the first row of the new simplex table. Next we apply the row operations for the second row. In the old simplex table, at row 2 and x2 position, its value is the 1. But we have to get the its value is the 0. So when we will get the 0 mean 1 minus 1 equal to 0. So we can be say that one the R2 old minus R3 new. So next our row operation is the R2 new equal to R2 old minus R3 new. So first write down the R2 old elements, that is 30, 1, 1 and 3, 0, 1 and the 0. So next to write down the R3 new elements, that is the 8 and 1 by 3, 1, 1 by 3, 0, 0, 1 by 3. So next we have to do the operation is R2 volt minus R3 new, that is 30 minus 8, which is the 22, 1 minus 1 by 3, 2 by 3, 1 minus 1, 0, 3 minus 1 by 3, which is equal to 8 by 3, 0 minus 0, 0, 1 minus 0, 1 and 0 minus 1 by 3, which is equal to the minus 1 by 3. This is the new simplex table. Next we calculate the Zj minus Cj values and check the basic feasible solution for the optimality. First we have to calculate the Z1 minus C1 for the first basic variable, that is for x1. So for the x1, Z1 minus C1 equal to the 0 into 1 plus 0 into 2 by 3 plus 5 into 1 by 3 minus 3, which is equal to the 5 by 3 minus 3, which is equal minus 4 by 3. Next for the Z2 minus C2 for the x2 variable, that is 0 into 0 plus 0 into 0 plus 5 into 1 minus 5, which is equal to the 5 minus 5, which is equal 0. Next is the Z3 minus C3 for the x3 variable, that is 0 into 0 plus 0 into 8 by 3 plus 5 into 1 by 3 minus 4, that is 5 by 3 minus 4, which is equal to the minus 7 by 3. Next one is the Z4 minus C4 for the S1 variable, that is 0 into 1 plus 0 into 0 plus 5 into 0 minus 0, which is equal to the 0. Next one is the Z5 minus C5 for the S2 variable, that is 0 into 0 plus 0 into 1 plus 5 into 0 minus 0, which is equal to the 0. Next one is the Z6 minus C6, which is equal to the 0 into minus 1 plus 0 into minus 1 by 3 plus 5 into 1 by 3 minus 0, which is equal to the 5 by 3. So here observe the all the Zj minus Cj is not greater than or equal to the 0. So we are not obtain the optimal solution. And one more thing observe here. Here more than the one Zj minus Cj is the negative value, then you have to choose the most negative value, that is minus 7 by 3 for the x3 variable. So x3 variable we are calling as the incoming variable, and the x3 column is the key column and it is calling as the incoming vector. So x3 variable enters into the basis. Next we calculate the minimum ratio of xp divided by ck value. So first we have to calculate the xp divided by ck for the first row, that is the for the S1 row. For the S1 row, xb value is the 6 and ck value is the 0. Here we have to remember ck value always should be the greater than the 0. Then for this one, for the first row or S1 row, we are not considering the xb by ck value. So next we have to determine the xb by ck value for the second row, that is for the S2 row. For the S2 row, xb value is the 22 and ck value is the 8 by 3. Then xb divided by ck equal to the 22 divided by 8 by 3, which is equal to the 22 into 3 by 8, which is the 66 by 8. This value is the 8.25. Similarly, next we have to calculate the xp divided by ck for the third row, that is for the x2 row. For the x2 row, xb value is the 8 and ck value is the 1 by 3. Then xb by ck equal to 8 divided by 1 by 3, which is equal to the 24. So here observe the among the all the xb divided by ck values, minimum value is the 66 by 8 for the S2 row. So this S2 row we are calling as the key row, and this S2 row we are calling as the outgoing vector, and here S2 variable is the leaving variable. So basic variable S2 leaves from the basis. Next we have to identify the common element in the key row as well as the key column. Here key column is the x3 column and key row is the S2 row. So among the key row and the key column, common element is the 8 by 3. So 8 by 3 is the key element. So next step is we have to construct the new simplex table by entering the incoming vector. Now we construct the new simplex table by entering the x3 variable in the basis in the place of the x2 and enter the its cost coefficient value is the 4 in the CB column. So now we apply the following row operations to get the 0, 1, 0 in the x3 column of the new simplex table. So first row operation is the first I have to look for the second row, because second row is the it is the key row. So first I have to look for the second row, and for respected second row, row operation is the R2 new equal to R2 old divided by key element. So here key element is the 8 by 3. So R2 new will become the R2 old divided by 8 by 3, which is equal to the R2 old into 3 by 8. So it will become the first I have to write down the R2 old elements, that is 22, 2 by 3, 0, 8 by 3, 0, 1 and minus 1 by 3. So then I have to multiply with the 3 by 8, then R2 old into 3 by 8, it is the become the 22 into 3 by 8, 66 by 8, 2 by 3 into 3 by 8, so it is become the 1 by 4, 0 into 3 by 8, 0, so 8 by 3 into 3 by 8 which is equal to the 1 and 0 into 3 by 8 which is the 0, 1 into 3 by 8 it is the 3 by 8 and minus 1 by 3 into 3 by 8. So 3 will get cancelled, it will become the minus 1 by 8. So I have to enter these values in the new simplex table at the second row. Next we perform the another row operations for the third row. So that is R3 new equal to R3 old minus R2 new divided by 3. So first to write down the R3 old elements, that is 8, 1 by 3, 1, 1 by 3, 0, 0, 1 by 3. Similarly write down the R2 new elements, that is the 66 by 8, 1 by 4, 0, 1, 0, 3 by 8 minus 1 by 8. So next we perform the R2 new divided by 3. So which will become the 66 by 8 into 1 by 3 which is the 22 by 8 and similarly 1 by 4 into 1 by 3 which is equal to the 1 by 12, 0 into 1 by 3 0, 1 into 1 by 3 1 by 3, 0 into 1 by 3 0, 3 by 8 into 1 by 3, 3 will get cancelled, it is the 1 by 8. Next to minus 1 by 8 into 1 by 3, so 8 3 is a 24, so then minus 1 by 24. So next we have to perform the row operation is R3 old minus R2 new divided by 3, that is 8 minus 22 by 8 which is equal to the, so 8 is the LCM, 64 minus 22 it is the 42 divided by 8. Next we have to perform the 1 by 3 minus 1 by 12, so 12 is the LCM, 4 minus 3, so 3 divided by 12 which is the 1 by 4. So next one is the 1 minus 0, it is the 1 and 1 by 3 1 minus 1 by 3 0, 0 minus 0 0 and 0 minus 1 by 8 minus 1 by 8, 1 by 3 minus of minus 1 by 24 which is the 1 by 3 plus 1 by 24. So 24 is the LCM, then it will become the 3 by 8. So next we have to perform the another row operations for the R1 new. So R1 new will become the R3 old only, because here in the old table in the R1 row, similarly for the X3 column, so 0 value is having, so we should have to get also 0 also, then no need to modify the R1 old row. So then the R1 new is equal to the R3 old. So we have to fill these values with the same values of the old table. Next once again we have to calculate the Zj minus Cj and check the basic feasible solution for the optimality. So first we have to determine the Z1 minus C1 for the X1 variable, that is the 0 into 1 plus 4 into 1 by 4 plus 5 into 1 by 4 minus 3. So which is equal to the 0 into 1 0, 4 into 1 by 4 1, 5 into 1 by 12 5 by 12 minus 3. So 1 plus 5 by 12 minus 3 which is equal to the LCM is the 12, then 12 plus 5 minus 36 divided by 12 which is equal to the minus 19 by 12. Next is the Z2 minus C2 for the X2 variable, it is the 0 into 0 plus 4 into 0 and 5 into 1 minus 5. So 5 into 1 5 minus 5, it is the 0. Next one is the Z3 minus C3 for the X3 variable, it is the 0 into 0 plus 4 into 1 plus 5 into 0 minus 4. So here 4 into 1 4 minus 4, it is the 0. So next one is the Z4 minus C4 for the S1 variable, that is the 0 into 1 plus 4 into 0 plus 5 into 0 minus 0, this value is the 0. So next is the Z5 minus C5 for the S2 variable, it is the 0 into 0 plus 4 into 3 by 8 plus 5 into minus 1 by 8 minus 0. So then this value will become the 4 into 3 by 8, it is the 12 by 8 minus 5 by 8. This value is the 7 by 8. So next one is the Z6 minus C6 for the S3 variable. It is the 0 into minus 1 plus 4 into minus 1 by 8 plus 5 into 3 by 8. So this value is the 4 into minus 1 by 8 minus 4 by 8 plus 5 into 3 by 8. So plus 15 by 8. So LCM is the 8, then minus 4 plus 15, it is the 11 by 8. So here observe the, except the Z1 minus C1, remaining all the Zj minus Cj values are positive. So here only one Zj minus Cj value is the negative. So that is for the, so Z1 minus C1 for the X1 column. So Z1 minus C1 for the X1 column is the negative value. Have to select the X1 column as the key column, and X1 variable is enter into the basis. So next we have to calculate the minimum ratio of XB divided by CK. So first we have to calculate the XB divided by CK for the first row, that is the for the S1 row. For the S1 row, XB value is the 6 and the CK value is the 1, 6 by 1, it is the 6. Next for the second row, XB value is the 66 divided by 8 divided by 1 by 4, which is the 66 by 8 into the 4, which is value is the 33. So next for the third row, XB by CK value is 42 by 8. So divided by, so 1 by 4, which is equal to the 42 into 4 by 8. So here it is the divided by. So 42 into 4 by 8, which is equal to the 21. So here among the all the XB by CK values, minimum value is 6. So for the S1 row, so and the S1 row we are calling as the key row, and here S1 variable is leaves the basis. So next we have to observe the common element among the key row and the key column. So here common element is the 1, and this 1 we are calling as the key element. So next once again I have to construct the new simplex table by entering the incoming vector. Now we construct the new simplex table by entering the x1 variable in the basis in the place of the S1, and similarly enter the its cost coefficient value is the 3 in the CB column. Now we apply the following row operations to get the 1 0 0 in the x1 column of the new simplex table. First we have to observe the first row. For the first row there is the no need of the any row operation, because in the old table, so first row and the x1 column its value is the 1. So we have to get the value also 1. So there is no need of the any row operation. Then we can be written as R1 new equal to R1 volt. So enter the R1 new values are the R1 volt values, that is, so R1 volt values are the 6 1 0 0 1 0 minus 1. So next we have to look for the, so second row, that is the R2 new. So R2 new equal to R2 volt minus R1 new divided by 4. So first I have to write down the R2 volt elements, that is 66 by 8, 1 by 4, 0, 1, 0, 3 by 8 and the minus 1 by 8. So next to write down the R1 new divided by 4, that is the 6 by 4, 1 by 4. So 0 by 4 is 0, 0, and 0 by 4 is 0. 1 by 4 is the 1 by 4, 0 by 4 it is the 0, and minus 1 by 4 it is the minus 1 by 4. So next we have to perform the R2 old minus R1 new divided by 4, that is 66 by 8 minus 6 by 4. So LCM is the 8, that is the 66 minus 12 by 4. So 66 minus 12 divided by 8, which is equal to the 27 by 4. Then the 1 by 4 minus 1 by 4, it is the 0, and 0 minus 0, 0. 1 minus 0, it is the 1, and 0 minus 1 by 4 minus 1 by 4. 3 by 8 minus 0, it is the 3 by 8, and the minus 1 by 8 minus half minus 1 by 4, it is the minus 1 by 8 plus 1 by 4, and its value will become the 1 by 8. So next we have to look for the third row, that is the R3 new equal to R3 old minus R1 new divided by 4. So first I have to write down the R3 old elements, that is the 42 by 8 and 1 by 4, 1, 0, 0, minus 1 by 8 and the 3 by 8. So next I have to write down the R1 new divided by 4, that is the 6 by 4, 1 by 4, so 0, 0, 1 by 4, 0 and minus 1 by 4. So next I have to perform the R3 old minus R1 new divided by 4, that is the 42 by 8 minus 6 by 4. So LCM is the 8, then 42 minus 12 divided by 8, it is the 30 by 8, which will become the 15 by 2. So next one is the 1 by 4 minus 1 by 4, 0, 1 minus 0, 1, and 0 minus 0, 0, and 0 minus 1 by 4, it is the minus 1 by 4, and next one is the minus 1 by 8 minus 0, it is the minus 1 by 8, and next one is the 3 by 8 minus half minus 1 by 4, it is the 3 by 8 plus 1 by 4, which is the 5 by 8. Next we calculate the Zj minus Cj values and check the basic feasible solution for the optimality. So first I have to calculate the Z1 minus C1, so that is the 3 into 1 plus 4 into 0 plus 5 into 0 and minus 3, its value is the 0, and next one is the 3 into 0 plus 4 into 0 plus 5 into 1 minus 5, it is the 0, and next one is the 3 into 0 plus 4 into 1 plus 5 into 0 minus 4, its value also it's a 0, and next one is the 3 into 1 plus 4 into minus 1 by 4 plus 5 into minus 1 by 4 minus 0, then its value is the 3 into 1, 3, and 4 into minus 1 by 4, its value is the minus 1, and 5 into minus 1 by 4, its value is the minus 5 by 4, then 3 minus 1 and 5 by 4, and LCM is the 4, then the 12 minus 4 minus 5 divided by the 4, it is the 3 by 4. So next one is the 3 into 0 plus 4 into 3 by 8 plus 5 into minus 1 by 8 minus 0. So then the 3 into 0, 0, and 4 into 3 by 8, that is the 12 by 8 plus 5 into minus 1 by 8, it is the minus 5 by 8. So 12 by 8 minus 5 by 8, then the value is the 7 by 8. And next one is the 3 into minus 1 plus 4 into 1 by 8 plus 5 into 5 by 8 minus 0, and here so 3 into minus 1 minus 3 plus 4 by 8 and plus 25 by 8. So here LCM is the 8, then 24 plus 4 plus 25 divided by 8, it is the 5 by 8. So here observe the all the Zj minus Cj values are the positive values, and so all the Zj minus Cj values are the greater than or equal to the 0, then we got the optimal solution. Then optimal basic feasible solution will become the, for the x1 we have to observe the xb value is the 6. So x1 equal to the 6 and x2 value is the 15 by 12, that is the 7.5, and x3 value is the 27 by 4, that is the 6.75. Then given objective function is maximize z equal to 3x1 plus 5x2 plus 4x3. Then optimal solution is the substitute the x1, x2, x3 values in the objective function. Then z will become the 3 into 6 plus 5 into 7.5 plus 4 into 6.75. So its z value is the 82.5. So this is the solution, and thank you very much.